series resistor and Ohm's law. So let's start with this simple circuit. What's going on in this circuit? You get our power supply, you get our switch, our light bulb, and two instruments to measure the current flow and then the voltage. So this is alternative current. What do we get like parameters in this circuit? We get the voltage here, or the voltage in our resistor. The voltage, the unit is V, and then we have the current flow through our circuit, the I, and the unit is A, and we get the resistor of our electric bulb, R, like a resistor, and the unit is ohm. So what do we have? Note that the ammeter is in series with our resistor. If you were to put your ammeter in the circuit, just cut the line and then you put the ammeter in your circuit in series. But if you want to put your voltmeter, you put it in parallel with the resistor on which you want to measure the voltage drop. So we get the current that flows through the circuit equal V over R. We can write from this R equal V over I. And so E equal R times I is known like Ohm's law. This relation is very important. It's a fundamental relation for one who study electric circuit. So if V equal 230 volts and R equal 400 ohm, we get I equal V over R. I equal 230 divided by 400 equals 0.575 amps. So the current that flows through our circuit is 0.575 amps. This circuit is very simple. Let's go to another one. This is two light bulbs in series, R1 and then R2. So the current that flows through R1 is the same that flows through the R2. Because there is no choice. The current that came here has no choice. Here, if we go to R1, he has to go to R. He has to go to R2. So that current is the same through all the circuits. So we can write I R1, the current that flows through R1, equal I R2, the current that flows through R2, equal the total current in our circuit. And we know that the voltage, the total voltage is the sum of the two voltage as we get two resistors in our circuit. So Vt equal V1 plus V2, and so RT times I, which is Vt equal R1 times I1 plus R2 times I2. So RT times I equal R1 times I plus R2 times I. We can cancel I, and then you have RT equal R1 plus R2. And if the resistors are in series, to get the effective resistor or the total resistor, you just need to add all the resistors in series. If R1 equal 400 ohm and then R2 equal 300 ohm, you get RT equal 700 ohm. This is very, very simple. We get this circuit with three resistor in series. As we've seen before, the current that flow through R1 is the same that flow through R2, and then that current is the same that flow through R3. The current, the total current is the same, and this current is measured by our ammeter that we put in series. And then if you need to read the voltage drop on R2, we put our voltmeter in parallel on R2. So the total resistance is the sum of all the resistance. RT equal R1 plus R2 plus R3. So whatever the number of the resistance you have, the total resistance is the sum of all the resistance in circuit. This brings you to get a simple circuit where you have only one resistor that represents the total resistance, the sum of the total resistance you get in your circuit. By example, if you get R1 equal R2 equal R3 equal 400 ohm, we get the current that flows through the circuit is V, the total V over R, total R equal 230 divided by 1200. You get the current is 0.191 amps.